So this says determine the distribution of the data pictured below. But when we look at these answers here, they actually just want the shape of this distribution. So let's talk about these particular shapes. If a distribution is uniform, then that's a distribution where each particular category or each particular outcome is equally likely to occur. So if you imagine rolling a six-sided die, and like let's say I rolled a six-sided die 600 times, and I counted up the number of ones, twos, threes, fours, fives, and sixes that appeared, I'd have roughly the same amount of ones, twos, threes, fours, fives, and sixes. It wouldn't be precise. What, 1, 2, 3, 4, 5, 6? Good, I thought I had an extra one. So it wouldn't be exactly the same. In an ideal world it would, but in the real world, we'd have a little bit of random variation, but you'd have this roughly uniform shape. Bell-shaped. A bell-shaped distribution is when you've got a distribution that has, well, a bell shape to it. But what does that mean? If I were to roll 2 dice and add the 2 dice together, think about the outcomes, right? If I were to make a distribution that represents all the different ways that 2 dice could be rolled and then add them up, there's a lot more ways to roll a 7. In fact, if I said, what could I roll? I could roll a 2, a 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There's 6 different ways to roll a 7, right? There's a 1 and a 6 and a 1, a 5 and a 2 and a 5. So you end up with 6 different outcomes that have a sum of 7. If I wanted to make an 8, well then there's a 6 and a 2, a 5 and a 3 and a 5, and a 4 and a 4. Whoops, I forgot here the 3 and the 4 and the 4 and the 3. There's my 6 outcomes. For this, what, 4, 4, 3, 5, 5, 3, 6, 2, and 2, 6, there's 5 different outcomes that make an 8. And then if I keep listing them all out, but for the brevity here, I'm not going to list them all. There's going to be 4 ways to roll a 9, 3 ways to roll a 10, 2 ways to roll an 11, and only 1 way to roll a 12, right? The 6 and the 6. And then the 6 will also have 5 outcomes. The 5 will also have 4 outcomes, the 4 will have 3 outcomes, the 3 has 2 outcomes, and the 2 has 1 outcome. And you end up with this roughly bell shape. So you've got a lot of data here in the middle, and then not a lot of data out in the tails. And it has this nice but symmetric distribution where you can split it in half, and you can fold this half of the data onto that. So this would be roughly bell-shaped. Skewed right is when you've got a distribution that has a lot of data in one end and then this long tail hanging off the other end. So if I have a distribution of, say, incomes of people that happen to work at a large corporation, you might have a lot of people making money down here in the, maybe the $30,000 category, the $40,000, the $50,000 category, but then it's going to tail off, and there's going to be fewer and fewer people up here, and maybe this is the CEO making some amount of money out there to the tail. So you end up with this distribution that is going to be skewed right. A lot of people think that that's skewed left because you have a lot of data over here on the left, but no, it's skewed in the direction of the tail. So this would be right skew. And then if we had maybe a distribution of ages, maybe in a country where there weren't that very many children being born, but there were a lot of older people, then maybe I would have ages down here, and I'd have not very many people in these young categories, but then I had a lot more people up here in the older categories, and so then I would have this left skew distribution. So then we take a look at what we have here, and we go, well, I have this tail hanging off to the right, so therefore this must be a skewed right.